Okay, so what we are going to introduce or start talking about for the next day and a week is something called a radical. And a radical, when I refer to the word radical, you probably know the square root symbol, okay? That's the most basic radical there is. So let's at least just talk about what a root is. And then I don't know if I know that you learned this in Algebra 1 at some point, but that doesn't mean you remember it. Radicals are also the same thing as exponents written as fractions. So we're just going to try to familiarize and go back and forth between those two things really today. All right, so I think probably you know your square roots pretty well. And I put them in here. And you see on your root card your square roots. These are the perfect squares. So the way that this root card works is this is the root and this is the square. So this would mean it's all shiny. The square root of 4, if you look in your perfect squares, is 2 because 2 squared is 4. Okay, if we keep going down, the square root of 25 is 5. So this kind of summarizes what all the roots are. But there are different kinds of roots. There are also cubed roots. So they work in the same way. The cubed root of 8 is 2, but this time it's a cubed root. So the reason why is because 2 cubed is 8. Did you guys know this already about roots? Kind of? Okay. There's even fifths. Okay. So like the fifth root of, I know, but do you really know fifths in your head? No. That's why I gave you this root card. So the fifth root of 1024, for instance, would be 4 because 4 to the fifth is 1024. So these root cards are just going to help us a little bit in case when we have to pull out roots and you're not remembering what some of those roots are. You can use a calculator too to help to see if some of those go in. All right, so I'm pretty sure you're familiarized with these, but use the root card or this table for some other roots. So in general, a radical is written as a rational exponent. The word rational, if you're just like, what? That's a lot of vocab. That just means fraction. Okay. So the most basic ones would be the square root, I'll just write it in general, of x is the same thing as x to the 1/2 power. I hope that makes sense to you because it undoes squaring. So it's 1/2 power. What do you think the cubed root is? So first of all, the cubed root, I put a little 3 in the corner there. What do you think that is the same as? Yeah, that's like x to the 1/3 and so on. So in general, if I had a fourth root, that's x to the 1/4. In general, those two expressions mean the exact same thing. And we would call this the square root. Do you notice there's no 2 there? If you want to put a 2, and I would never mark that wrong, but we just don't do it for squareds. Cubed root, fourth root, fifth root would be the 1/5. Okay, let's take out our root card quickly a second. What's the square root of 16? Okay, what about cubed root of 8? So you go in your perfect cubes, you look for your 8. The root is right here. It's 2. I'm just trying to show you how this works. The cubed root of 27. You go to your cubes, you find 27. The cubed root of 27 is 3. The fourth root of 16. You go to your fourths. You look at the root. Are there any questions on how to use the root card? I know I went kind of faster. Okay. This is a nice little diagram, I think, that helps us explain what if the fraction doesn't have a 1 on top? How do I handle that? And so when I have a fraction raised to, or a base raised to a fraction exponent, the top of the fraction, we're going to just raise the radical symbol or radical expression to that. It just becomes the exponent. And the bottom number on the fraction or the denominator is just the root, okay? So, for instance, I have another one here. If I had x raised to the m over n, it's x to the m, that's the exponent, and the root, the bottom goes right there. By the way, it does not matter if you put the exponent, the m, inside, or you can put it outside. I do kind of tend to do either or, okay? You can do either or. All right, so let's just practice rewriting these as fraction exponents. See if you can do some on your own. So if it's just the square root, we said this already, this would be a to the 1/2. If it's a cube root, this is a to the 1/3. Okay, let's go slow here. If it's the 5th root of a squared, we take the a squared, that becomes the top of my fraction exponent, so it's going to go up here, and the 5th is going to go on the bottom, so this is a to the 2/5. Be careful of square roots because the number's not written down there. If you want, you could put the little square root in there. This is a to the 3/2. Just kind of give me an indicator. Am I going too fast? Is this making sense? Is this not good? Okay. Okay. So we're going to kind of go back and forth with writing as rational exponents. This time, just pay attention to also the instructions. This time, they're not variables. They're numbers, so we're going to rewrite as a rational exponent, and then we're going to use our root card to simplify, okay? And I threw some negatives on there just to mix things up. So this means negative 125 to the 1/3 power. That's if I asked you to write it as a rational exponent. And it's the cubed root of negative 125. What do you think that is? Well, the cubed root of 125 is 5. What do you think the cubed root of negative 125 is? Negative 5, because negative 5 times negative 5 times negative 5 would give me negative 125. And you might think, Miss Comrie, I thought you told me we couldn't do that with square roots. You're right, you can't do it with square roots because that's impossible. But you can do it with cube roots because you're multiplying 3 times, and the negative times a negative times a negative would be negative. So you can have negative odd roots, not even roots. Okay. If you do see a negative, it would just be on the outside like this. This is saying negative 2 times the 4th root of 16. So let's get on our root card. What's the 4th root of 16? The 4th root of 16 is 2, okay? And so then I simplify this part. This is negative 2 times 2, or negative 4. Okay, would you guys try the last two on your own? Okay, how'd we do? All right, now I'm going to have you guys try this top row on your own. Can you try writing these in exponent notation? So they're fraction ones. Okay. We just did a couple examples. Just try the top three. The bottom three are a little trickier. Okay, so first of all, if you see the word rational, that just means fraction. If you want to just kind of solidify that because I know you might not be familiarized with that word. This, you should have gotten x to the 1/2. This one is just x to the 1/3. This one, this 2 is on top of the fraction and the 3 is on the bottom, x to the 2/3. How did we do? Okay. Okay, now let's do some more challenging ones, okay? So I'm trying to have you write this as a rational exponent. And now this one, there's not a lot of simplifying we can do, but that's why I pay attention to the instructions. We're just going to rewrite it. How can I rewrite the square root? What exponent did we say that is? The square root is what exponent? 1/2? 1/2? So I'm going to take out that square root symbol, and I'm going to rewrite this as a cubed minus b squared. And this thing that I highlighted is to the 1/2. Do you also see that there's a squared on the outside? Okay, so I have the squared out there. Now, be really, really careful. We're not going to kill cats here. You cannot distribute a power when there's subtraction in there, okay? The only thing you can do, let's see how good your memory is. We're not slotted to cover this till next week, Thursday. Do you remember what a power to a power is? What you do with those? Turn and talk to your neighbor if you think you remember. If you have 2 exponents, it's a power to a power. Did you say you multiply them? I heard it somewhere. Somebody said it, not all of you. What's 1/2 times 2? 1. So those just cancel, and it's just a cubed minus b squared. So I could simplify that a little bit. Okay, let's do the next one. What if I have a whole group like this, okay, and I have a square root? We already determined that's xy to the 1/2, and then that 5th out there, I can do the same thing. I'm going to just rewrite 1/2 times 5 is 5/2. Are we all okay with that? 1/2 times 5 is 5/2. So I'm just trying to follow the example that says positive rational exponent. So I could rewrite that as xy to the 5/2. What about when you have something outside and inside? You can't do anything with this y, but how would I rewrite the z? This is a 6, and that's an 11th root. Whoa. Yeah, we can have an 11th root. It's a thing. That's y, and just the z is to the 6/11. Okay. How are we doing?
Did you not
Good.
multiply the 5 times 1/2?
I did.
You didn't want to
Oh, I just left. Yeah, because the instruction said leave it as a fraction exponent. Yeah, that's why. Just because the instruction said so. Okay, now let's go the other direction. Let's rewrite these in radical notation. Okay, remember? And I don't care if you put the 3 on the outside of the radical or on the inside. I'll show both ways. But the bottom number is your root. So this is the 4th root of x to the 3rd. And you might see me write it this way. Or it can also, this is another set of parentheses. It can also be written that way. I don't care how you write it. Just realize that the cubed applies to the whole radical. All right. X to the 6, feel free to work ahead if you want. X to the 6/5, that's the 5th root of x to the 6th. Be careful, I put these 2 on here because they're actually different. If it's written this way, only the x is raised to the 1/2. So this would just be 5 times the square root of x. But this one, what do you think about this one? This time, put the whole thing under the radical. So the whole thing, 5x, is underneath the square root. I throw a couple negative exponents on there because you did learn them before. Again, we're not slotted to relearn it till Thursday. A negative exponent means to take the reciprocal, okay? Reciprocal means flip it. So if I see this negative there, the very first thing I'm going to do is I'm going to do a 1 over xy to the 4/3. That's all it does. It does 1 over. And again, we're going to really kind of take some notes on that on Thursday. And then let's rewrite it. That's 1 over the 3rd root of xy all raised to the 4th. Make sure it's all raised. Okay, we're not getting through all these notes today. We're just going to now do our example 5, and then I save some of the other things for next week later on. Okay, this is the fun part. Get your root card out again. Now, when I say evaluate without a calculator, what I mean is use your root card. So, okay, because I want you to understand what the properties mean. That's why. Can you use your calculator to check your answer? Sure. So what we're going to do is we're going to break this up into the root and then the power. So what this really means is 9 to the 1/2. Do you see how, because the 2 is on the bottom? Raised to the 3rd. That's what that means. On our root card, this is a square root. What's the square root of 9? What's the square root of 9? 3. So the square root of 9 is 3, and then 3 to the 3rd, I can look on my root card again. 3 to the 3rd is 27. Okay. So when it's a negative, we're going to just make sure we put it on the bottom. So I'm going to make this one for 32 is 1 over 32 to the 1/5, because of the 5 on the bottom, squared. Now, some of you don't need to rewrite it like this. Some of you can just see it, and that's fine. But I'm going to do the 5th root of 32. Look on your root card. Look in the 5th row. The 5th root of 32 is 2. So 32 to the 1/5, I'm going to rewrite as 2. But then I have that squared there. Okay. I think you know 2 squared. What's 2 squared? So 1 over 4. Okay, this time the negative's not in the exponent. The negative's just the number. Okay, this is the 5th root of negative 32. Well, negative 32 isn't on my root card, but 32 is. What do you think the 5th root of negative 30 is going to be? Negative 32 is going to be negative 2. So this is just negative 2. And this is what we're going to do some whiteboard practice with in a second. Okay, so just to make sure you got it. All right, how do we do this one? The exponent is negative, so this is going to be 1 over 64 to the 1/3, so the 3rd root of 64, and then squared. All right, so I look at my root card at my cubed roots of 64. The cubed root of 64 is 4. This is 1 over 4 squared. And what is 4 squared? 16. This one's written in radical notation. This is a 4th root of 16. Okay, so I go to my fourths again. What's the 4th root of 16? It's 2. And then 2 squared is 4. Yes? Oh, you're Jolly Ranchering me? Yeah. He said, how did the 1 go away? It didn't. You can get a Jolly Rancher. That should be 1 over 16. Thank you. You just didn't bring it to my attention. All right. Oh, weird. What if it's 1 over 64? How do you think I flip it? Go the other way. Flip it around. 1 over 64. We're going to flip to 64 over 1. I don't really need the 1 on the bottom. To the 2/3. And that would mean I need to do 64 to the 1/3. I think I did this one already. Squared. Oh, I did that here, but as a fraction. So it's going to be the reciprocal then. What's 64 to the 1/3? So I look here, 4. 4 squared is 16. I know, maybe I did. I wish that was the reason, but it's not. Okay. Very nice job. You already grabbed your whiteboards. Just one word of warning. What if I give you something that you can take the root of, or that you can square or whatever, but then you don't get the root back? So what I mean is, what if I had something like this and I have it on this section? When you have two, a radical and a root, you can do them in any order you want. You just have to do both of them, okay? So I could rearrange this to do 8 to the 1/3 first and then take the square root is what I'm saying. Do you know the cubed root of 8 from your root card? What is the cubed root of 8? 2. But then I get to this part and I'm like, I don't know the square root of 2. Well, then you leave it. That's all you can do. It's not, yeah. So you might run across that on your assignment on Tuesday. All right.